Hello everybody, welcome back to From Rhythm to Algorithm Part 12, Shape and Sound. This is going to be a lesson in geometric linguistics. Geometric linguistics is a sub-subject of dimensionless analysis. It'll be a part lecture, part research directive. There's a bunch of open questions that we can now ask and categories of open questions we can ask. I'm supposed to be talking you through the logic there, just thinking out loud. So there's a couple, because remember, language is defined in complete generality. When you derive the proper definition of the word, the definition is going to already apply in every context, in every domain of scientific ontology. Another thing I wanted to say, just for a way for you to think about the difference between vocabulary and ontology from the last episode. Does theoretical physics exist? Yes. Do theoretical physics students exist? Yes. So literally the difference between ontology and vocabulary is a physics student trying to literally go to school and learn how to talk about an ontology properly. The words that exist, like I said, in 500 years, everyone today will be dead and gone. So the logic is already set in there, and it's the person learning to the ontology. But some more principles or ideas that are still not clear to me physically. Symmetry maps shape under rotation. I have my marker here. If I rotate it 360 degrees, we come right back to the same positioning. So to me, symmetry, really easy to see with letters, but symmetry, when I say symmetry maps shape under rotation, two things I wanted to point out. I explicitly have under rotation and not translation, under rotation and translation, because I'm not sure the relationship of symmetry, rotation, chirality, reflection, and translation. But, which letters of the English alphabet can you rotate and produce another, rotate or flip or reflect in any way and produce another letter of the alphabet or of the English alphabet or of the Roman alphabet or a different alphabet, like the Cyrillic alphabet? Just some examples, right? N in the English language, or in the Roman alphabets, N, and then the sound E in the Cyrillic alphabet is it's the N backwards kind of. So that's symmetric under a flip rotation. If you flip the letter N in English, you get the letter E in Russian or in Cyrillic. So that's just what I mean there. And you can see, like I said, I don't have, that's a class or category for someone else or for a big research project. What numeric statements can you make about the structure and symmetries about sentences, about letters, about words? What statements and sets can you produce about logic to words, right? We pointed out that logic is the opposite, right? That's why people say there's no rhyme or reason to something. Rhyme or reason. That's a differentiation we've already made. But how more specific can we make those statements? Those are all open questions in geometric linguistics. Chirality is non-symmetric under reflection. You'll hear chirality in chemistry class. And so if you go do a demonstration, go take a picture, hold something in your left hand. When you take a picture, it's going to appear on the picture in your right hand. So reflection flips direction. And if you can map the shape in the same way, N and E, you could physically cover, or map the two letters. Chirality is once you take that, once it flips the direction, can you rotate the initial shape in any way to map or cover the chiral shape? And the reason this exists is because the universe is not, and then I have up here bringing chemistry and linguistics to cosmology. the universe is not left-right symmetric. I think right now in public conversation, physicists will say they don't know. It is not. And the reason is the physical stabilization moments. I'm not super clear on this right now, or I'm forgetting something, or I've already covered something. But like I said, at the electron level, how does an electron know it's not a proton? So the word "know" for an electron and proton's kind of weird. But from vibration to radiation to matter, there's some geometric argument just again about odd number polygons not having a center. That somehow produces symmetry, and that's why the universe is not left-right symmetric. And then I put the line through it because it's not symmetric at all. I'll have to do more work there. That's kind of on me. But how does chirality affect word, syllable, and letter order? That's what I was just saying about open categories of questions. Don't even know what questions to ask, but it's very accessible, right? Just go take a statement of logic and just look at the shapes of letters and see what you can come up with it in terms of geometry, symmetry, blah, blah, blah. And now for actual literal geometry, what another research directive is, look at the letters and say which letters are curved and which letters are straight. What's the difference? Why do we represent capital letters with different shapes than lowercase letters? Why have we paired these shapes to these sounds in any alphabet? All completely novel open questions. But how about if you set each, right, like just using the letter N again, what if you dissected the letter N into 3 line segments? 4 vertices and 3 line segments, and right, it's not a closed shape. So what standard geometric arguments can you say about letters as is? And then, like, can you make some sort of, right, like I said, that's just one example. Can you make some sort of like actual ratio calculation of the shape of P, right? Okay, well, if you erase the lower line of P, you get D. What kind of modifications to the letters what kind of symmetries can you produce within geometric linguistics is kind of different. Or again, just not known. But I think that's the motivation should be try to set every line segment of a letter to a unit 1, and then try to see how if you can calculate any relationships between the letters. And this is also very structured. Geometric linguistics is very easy to see with fonts, right? When you're reading on your cell phone or on your computer, you'll notice instinctually it's something that's misaligned. It's not centered right, or it's out of the way. That's all geometric linguistics at an instinctual level. So those are the concepts I wanted to cover: symmetry, chirality, rotation, reflection, translation. Not exactly sure the relationship there. We should be able to draw some definitive numeric statement from all of this. But I did want to give, like I said, this is a great research directive for other students and for other mathematicians. So thanks for watching From Rhythm to Algorithm, Part 12, Shape and Sound.